Welcome! In this video we will discuss the basics of coordinate reference systems and how they are used in PIX4Dmatic. Coordinate reference systems allow us to accurately place a project on the map and ensure the project can be discussed in relation to others in the vicinity. Due to the complexity of this topic, we will only discuss the basics and how to select the appropriate coordinate reference system in PIX4Dmatic. More information can be found in the PIX4D Technical Support Knowledge Base and other instructional materials. When working with PIX4Dmatic, there are three coordinate reference systems to be aware of. This video will concentrate on working with known coordinate reference systems, or CRS for short. The image coordinate reference system is assigned automatically to the images when captured. For most imagery, including drones, the WGS84 horizontal coordinate reference system is used. If you are working with PIX4D Catch without connecting to a compatible RTK device, the images will be captured using WGS84 for the horizontal CRS and EGM96 for the vertical CRS. If you capture images with PIX4D Catch connected to a compatible RTK device or are flying an RTK-equipped drone, the images will be captured using the N-Trip input coordinate reference system. The image coordinate reference system is always a geographic CRS. When the necessary values are not included in the image's metadata, or you are working with a PPK workflow, you can upload a CSV or TXT file containing the image geolocation information. To learn more about how to do so, please consult the PIX4D Technical Support Knowledge Base. The Ground Control Point, or GCP, coordinate reference system is defined by the CRS used to record the GCPs. This coordinate reference system is selected when the GCPs are recorded and needs to be clearly communicated to ensure the correct CRS is selected when processing the imagery. Using the EPSG or Esri code ensures that the horizontal and vertical coordinate reference systems are correctly communicated. If you select the wrong horizontal or vertical coordinate reference system when importing the GCP data, your deliverables will be inaccurately geolocated. If you have any doubts, request the CRS code from the person who recorded the points in the field. To select the GCP coordinate reference systems in PIX4Dmatic, you must first enter the horizontal CRS. Once you have chosen the horizontal CRS, the vertical CRS will be filtered based on your selection. If necessary, select the appropriate geoid or enter the geoid height. Due to the complexity of choosing the correct vertical coordinate reference system or geoid, we will discuss each separately. A vertical coordinate reference system provides a framework to measure elevations or heights along the z-axis. Heights can be defined either by an ellipsoidal height or an orthometric height. Ellipsoidal heights are measured from the surface of a mathematically defined ellipsoid that approximates the overall shape of the Earth. In contrast, orthometric heights are measured based on the geoid model, an equipotential surface closely approximating mean sea level. Vertical coordinate reference systems are established for specific locations. A geoid model is associated with one or more vertical CRS and is used to transform ellipsoidal heights to orthometric heights within the extent defined by the vertical CRS. PIX4Dmatic supports global and local geoids. To select a geoid, it is necessary to first define the vertical CRS. Based on the vertical CRS, the compatible geoids will be displayed. If your local geoid is included in the database, simply select the geoid and click Apply. If the desired local geoid is not included in the PIX4Dmatic database, you can either import the geoid or define the geoid height to convert to orthometric heights. To import a geoid, you must download the file containing the relevant information from the authorities in your region. It is only necessary to import a geoid file once. The geoid height represents the height between the base ellipsoid and the desired geoid. A geoid height will be automatically assigned depending on which vertical CRS you select and the location of the project. If the geoid height is not automatically identified, you must obtain these values from an external source. Where to find this information is dependent on your region. When working with GCPs, the GCP CRS defines the project CRS. When no GCPs are included in the project CRS is determined by the image CRS with the corresponding UTM zone by default. If you do not have GCPs for the project, you can modify the project CRS in the same way as you set the GCP CRS. It is important to ensure that the project coordinate reference system corresponds to the desired CRS of the deliverables. If you incorrectly set the project CRS, the geolocation of the deliverables will be incorrect, and the project may be shifted horizontally and/or vertically. We hope this tutorial video discussing working with coordinate reference systems in PIX4Dmatic was helpful. See you in the next video!